Quick note before we start, I am working with a teleprompter for the first time, so it might look a little weird. I might be looking slightly away from the camera because I don't have a lot of money and my version of the teleprompter is pretty cheap. Fine-tuning of the universe for intelligent life refers to the fact that, quote, messing with the makeup of the universe can have a disastrous effect on the emergence of complex life like you and me. In more detail, anthropic fine-tuning involves three related concepts: fine-tuning, fine-tuning of the universe, and fine-tuning of the universe for life. Just bear with me. In general, some parameter or feature is finely tuned if it must be confined to a narrow range of values to guarantee a certain outcome. So, a radio dial may be finely tuned in this sense that to listen to a certain station, the dial must be set precisely on the right value, and any deviation too far up or down or left or right, depending on how you think about it, would result in random static. The fine-tuning of the universe specifically refers to the fine-tuning apparent in two types of parameters in contemporary physics. First, the physical constants that appear in the standard models of particle physics and cosmology. And second, the initial conditions of the universe. The physical constants are those magnitudes or values that appear in the laws of physics and determine the particular manifestation of that law operative in our universe. For example, take Einstein's well-known law, E equals mc squared. E refers to energy, m to mass, and c to the speed of light. C is a constant in this equation. Energy and mass will change depending upon which physical object you're calculating the energy for, but the speed of light will never change when you apply this equation. In general, the physical constants are those quantities that determine either force strengths or particle masses. An example of the second kind of fine-tuned feature, the initial conditions, is the highly ordered state of the very early universe. The beginning of the universe was anything but random and chaotic, but was instead an incomprehensibly ordered and constrained process. So then, say that the universe is finely tuned for life means the range of life-permitting values for these constants and conditions is extremely narrow compared to the total range of possible values. Take a look at the graphic, absorb it, appreciate it. What are some examples of this fine-tuning, you ask? Well, the initial problem with answering this question is that simple and intuitive presentations of the relevant physics are liable to be gravely misunderstood, or misleading. Nevertheless, at least a few instances of fine-tuning are relatively easy for the non-physicist like me, and probably you, to grasp. Number one, the cosmological constant, lambda. This quantity expresses the energy inherent in space itself, an energy that, when positive, causes the universe to accelerate in its expansion, and when negative, makes the universe contract. Most physicists agree that lambda has a small positive value. According to physicist Luke Barnes, if this constant differed in its current value by 1 part in 10 to the 90th power, life could not exist anywhere in the universe. If it were slightly larger, the universe would have expanded too rapidly for stars and planets to form from interstellar debris, while if it were slightly smaller, gravity would have pulled the universe back in on itself well before life could evolve. Number two, the gravitational constant. This constant comes from Newton's law of gravity, which is right there for you to see. Right there. According to Robin Collins, if g were increased by 1 part in 10 to the 31, or 1 part in 10,000 billion, okay, it's going too fast, hold on, or 1 part in 10,000 billion, gravity on any planet would be too strong for any life larger than insects to evolve. Third, and finally, mass of the neutron. As you know, the nucleus of an atom is made of protons and neutrons. If the mass of the neutron were increased by 1%, then the neutrons would all rapidly decay into protons, and we would have no stable atoms aside from hydrogen. If the neutron mass were increased by 1%, protons would decay into neutrons, and the entire universe would be bland, neutron-only world. Either way, no life. Barnes calculates that the odds of all the constants and initial conditions that physicists talk about as being fine-tuned, taking on life-permitting values, is 1 part in 10 to the 136th power. That's 1 followed by 136 zeros. Really small. Oh, what explains why the universe is fine-tuned for life? I will briefly look at 4 answers to that question, 4 possible answers. The first is that chance alone is sufficient to account for fine-tuning. The motivation for this response is that improbable events happen all the time. and no one thinks there is some deeper explanation for their occurrence. So, for instance, while it is wildly improbable that I specifically will win the lottery, nevertheless, if I did win the lottery, I should not conclude that the outcome was rigged. It was just random. Somebody, after all, had to win, and any particular contestant in that lottery is equally improbable. In order to rule out chance, that event must meet two conditions. First, it must be improbable given chance, as we've seen. But secondly, it must be more probable given an alternative plausible hypothesis. Return to the lottery example. But this time, imagine that instead of you winning, the son of the CEO of the company that runs the lottery wins. In that case, appeal to the old, well, somebody had to win, and improbable events happen all the time, probably wouldn't cut it. And why not? Well, because there is an alternative plausible hypothesis according to which that particular person's winning is much more probable than if it happened randomly. Namely, the CEO of the company rigged the lottery so that his son would win. To show that chance is an implausible explanation for fine-tuning, we will have to investigate whether there is a plausible alternative explanation that makes fine-tuning more likely than chance alone. If not, then no matter how improbable fine-tuning is, we should not conclude that it was not due to chance. So it's a bit complicated, but there's the reasoning. Number two, the universe had to be life-permitting. This alternative would be the claim that the probability of fine-tuning is not in fact incredibly small, but is actually just one. A life-prohibiting universe is physically impossible. Our current theories of physics are incomplete. We know this. Quantum mechanics and general relativity are incompatible physical theories as they stand. We need a quantum theory of gravity, at the very least, before we can say that we've arrived at the final complete physics. The hope would then be that when this final theory comes into focus, what we thought had been free parameters, the cosmological constant, the gravitational constant, and so on, will actually turn out to be entirely fixed. The underlying physical theory will fix the values of these constants. We can derive them from the theory, and thereby providing an explanation for their various magnitudes and showing that we couldn't have had different values for them without changing the laws of physics themselves. I don't think that we should close the door on this possibility. Nevertheless, there are 2 points that undermine this alternative, at least in my mind. First, the progression of physics over the last 100 years has been towards more instances of fine-tuning, not less. To give just one example, in its early days, physicists hoped that string theory, as a final and unified theory of physics, would fix all of the free parameters and would explain why they had the values they do. But eventually, they realized that the theory, far from predicting the observed constants and initial conditions, allows for 10 to the 500th power different possible solutions. So explanations for these fine-tuned features in terms of deeper physics has not been the dominant historical trend, at the very least. Second, it would be remarkable and perhaps even miraculous if a life-permitting universe were physically necessary. If that were the case, wouldn't that look a little suspicious? Philosopher Philip Goff makes the point that life, especially conscious sentient life, is objectively valuable. And that is what serves to mark out the constants and quantities necessary for life as relevantly different from any other assortment of values, because it is only this precise combination that results in an outcome having objective significance and value. There was no chance that the universe developed in any other way. I think that would strike most of us as very strange and calling for a deeper explanation. And I think a reasonable inference to make in this situation is that a cosmic designer chose the laws of physics themselves, even if not the values for the constants featuring in those laws. How seriously one takes this alternative or this consideration will depend upon whether one thinks the laws of nature are contingent or necessary. And we do not have time to investigate those niceties. So I defer to a later date. Okay, the sun is going down and I'm running out of time. So the hues may look a little different now just because my phone died and then I had to, yeah. Anyway, so let's keep going. Number 3, we live in a multiverse. The idea here would be that there exists a huge, perhaps even infinite number of universes, and that in each universe, the constants take on randomly different values. And if the multiverse is sufficiently large, then somewhere, at some point, the constants will all strike a life-permitting combination. We happen to find ourselves in one such universe because, obviously, we couldn't have found ourselves in any other universe after all. An analogy we might give is the distance of the Earth from the Sun. Yeah, okay, this is going too fast. An analogy we might give is the distance of the Earth from the Sun. A planet closer to the Sun would fry, while a planet further away from the Sun would freeze. Mercury and Neptune, for instance, could never support complex life. We, of course, exist in that narrow band of distances from the Sun where life can exist. But crucially, we don't, or at least where the temperatures are compatible with life. But crucially, we don't infer some special explanation for this fact. Why? Well, because there are 8 other planets in the solar system randomly strewn about at random distances from the Sun, and it's likely that at least one planet would fall in the life-permitting distance range, and of course, we could only exist on that planet. And there are innumerable other star-planet systems throughout the universe. So we shouldn't be surprised to observe that we are within the life-permitting band. Similarly, with respect to all the fine-tuned constants and quantities of physics in a multiverse, it's the same kind of explanation. What should we say about this alternative as an explanation for fine-tuning? Well, in the philosophical literature, you will find a range of objections to the multiverse that I do not think are particularly rigorous or relevant, and I think it's an open question whether the multiverse will prove scientifically fruitful. Maybe it will. But let me make 2 comments that trouble me as a philosopher about the multiverse as an explanation for fine-tuning. First, the Boltzmann brain problem afflicts all multiverse models as far as I am aware. The problem here is that giant life-permitting universes like ours are vastly less likely to crop up in a multiverse than a single solitary brain that fluctuates into existence out of the quantum vacuum by chance alone and is surrounded by nothing but chaos. Such a fluctuation is massively improbable, but crucially, it is unfathomably more likely than the entire observable universe we observe existing in its low entropy state, fine-tuned for interactive, complex life. So at least given some probability framework, it is more likely that if the multiverse hypothesis is true, you are a single brain merely experiencing the hallucination of an external world and ordered universe around you, than you actually are an ordinary person in an ordinary universe. There are just so many more of those unfortunate isolated observers in the multiverse than there are ordinary ones. Physicist Sean Carroll calls this the cognitive instability inherent in multiverse models. And it is my understanding, at any rate, that physicists and cosmologists, while hard at work attempting to craft multiverse models that don't generate the Boltzmann brain problem, have not found one yet that works. If I'm wrong about that, please let me know in the comments. Second, philosopher Michael Rhoda makes the interesting case that even a multiverse wouldn't undermine the inference to a cosmic designer. Rhoda maintains that if God exists and creates a multiverse, it is likely that he would populate that multiverse with many life-permitting universes, because that would be a good thing to do and God is good. By contrast, given naturalism in a multiverse, it is likely that there would be relatively few life-permitting universes, given just how improbable they are, as we've seen. Rhoda offers an analogy. Well, this analogy I've adjusted, but he offers a similar one. There are 2 boxes in front of you, one with 99 white balls and 1 black ball, and one with 1 white ball and 99 black balls. The boxes are randomly shuffled. You then pull out a ball without looking inside. It is a white ball. With no other information, is it more likely that the ball came from the first box or the second one? The probability of drawing a white ball from the first is 99%, while it is only 1% from the second. So, with no other information, you should infer that the ball was almost certainly drawn from the first box. Now, return to the multiverse. In a theistic multiverse, there will be lots and lots of life-permitting universes. In a naturalistic multiverse, far fewer. We observe a life-permitting universe. Therefore, all else being equal, we ought to infer that we are in a theistic multiverse. The upshot is that even if the multiverse explains fine-tuning in a sense, it does not avoid inference to a cosmic designer. It's an interesting argument. I don't think it actually works, and I'll be delivering a paper with my critique at a conference in Poland later this year. I still have to write it though, so stay tuned. Fourth and finally, a cosmic designer set the constants and quantities in place. This alternative proposes, as you might expect, that an intelligent mind set the constants and initial conditions in place so as to guarantee that a life-permitting universe would result. They did... My monitor died. They did not take on their values randomly. Rather, it was by design. God wanted life to come into existence. It's pretty straightforward as an explanation. Is it a good one? Two caveats. I'm open to this hypothesis as the best explanation, but two caveats. First, inferring design behind the universe does not necessarily mean that God exists. After all, the bare hypothesis of design is compatible with the simulation hypothesis. For instance, the idea in one version anyway, that our universe is a simulated creation of a scientist in another universe, in the mother universe. Perhaps a bit more seriously, Philip Goff, is the world's most famous panpsychist, and he's argued that the universe designed itself. Now, with our Judeo-Christian background assumptions, we may find these alternatives bizarre and implausible. But as a philosopher, you have to evaluate those assumptions themselves and give all possibilities a hearing. All of this goes to say that even if one has concluded that fundamental features of physics were design, it would not follow, at least without some further argument, that it was God, or even anything recognizably godlike, that did it. Second, proponents of the design hypothesis will have to explain why it is likely that the designer would choose to make the universe life-permitting. Recall that in assessing whether one can write off fine-tuning as due to chance will all depend on whether there is a plausible alternative hypothesis that makes it more likely that the universe would be finely tuned for life than chance alone. So, to rule out chance and infer design, it must be the case that God would be more likely to design a fine-tuned universe than such a universe occurring by chance. But it's actually very difficult to come up with a convincing argument for thinking that God, the supreme and infinite mind far beyond our level of comprehension, would likely create a universe fine-tuned for life. Who are we to judge what such a mind would likely do? Philosopher Neil Manson has pressed this objection at length, and in my published work, I've referred to this as the divine psychology objection, because the point is that we seemingly have no rational grounds for making inferences about God's psychology, about what God would likely do in some circumstance. Even if one could show that God would likely create conscious beings, there are innumerable ways for him to accomplish that end. He could create physical life, non-physical life, a hybrid between the two, universes with different laws of nature that don't require fine-tuning, and because he's omnipotent, he can even create physical life in a universe that is not fine-tuned for life, just by sustaining them miraculously in existence. And who are we to say that God would be unlikely to do it that way? But that's the case. We can't rule out chance as an explanation for the fine-tuning of the universe for intelligent life. Now, I ultimately don't think this objection succeeds, and if you'd like to see why, then check out my paper titled Divine Psychology and Cosmic Fine-Tuning, available for free online, and there's a link in the description. Yep, that was a cheeky plug for my own work, and that's how things are going to roll around here. Thanks, everyone. If you liked the video, please subscribe. Goodbye.